Our Geopolímero Institute crew cast massive imitation pyramid blocks. Or perhaps we should say genuine pyramid blocks. We used the same kind of earthen ingredients available to the ancient Egyptians 4,500 years ago. These massive blocks have the same chemical makeup and appearance as blocks of the Great Pyramid. The limestone we used consists of fossil shells called nummulites, like those in the Giza bedrock. Like in Giza, our French limestone is so loosely bound it doesn't require crushing. But unlike in Giza, it contains no kaolin clay. We heap the cement additives, lime, natron and kaolin clay, near the limestone.
The two components will react in the water and build in situ geological glue, which will then yield the hard geopolymeric rock agglomerated limestone.
We start making the cement by mixing sodium carbonate, found in Egyptian natron, and lime in 500 liters of water. We then add the kaolin, inherent to Giza limestone, and stir the mix with a wooden tool. We dump 1 ton of limestone rubble into the basin and mix it with the cement. Several days later, water has evaporated from the basin, so we remove the disaggregated limestone for making the block. Inspecting the mixture, 95% limestone aggregates and only 5% rock-making binder. Between 12 and 17% of water give it the consistency of wet sand. One squeezes the mixture with his hand and it keeps its shape. This batch will quickly gain strength. We do all of the work manually, forming a human chain carrying buckets from the mixing area to the mold. We pour the limestone concrete mixture in a mold and pack it down with a tool called a rammer. Compacting the material requires little effort. The packing operation encourages cohesion and the denser mixture takes on high strength from the initial curing phase. When the climate is warm and beautiful, our crew rapidly produces a re-agglomerated limestone that proved strong, dense and true to the plant's size and shape. The mold consists of small wooden boards, which can be reused many times for making other blocks. In this ideal weather, the whole process runs smoothly and is very simple. We remove the mold 4 hours later. The synthetic limestone looks like a natural stone. We observed no trace of wood grain. 4 blocks have already been made. Davidovits presents them. The 2 large blocks weighing up to 4.5 tons, containing most water, have given smoother surfaces. The 2 small blocks weighing up to 1.3 tons, the least wet, take on rougher surfaces.
When you look at the stones of the pyramids, this is what you see. You see either smooth blocks or very crude blocks. And we have replicated all these surfaces just by varying the amount of water, which depends on the climate, which depends on the weather.
Joints between blocks are also perfect. It will take 3 months for the stones to fully cure because of the climate of northern France. In 4,000 years, will future archaeologists insist that our imitation pyramid stones are natural limestone? Ari-kat, the proven fact on how the pyramids were built. At last, a logical explanation of how the ancient Egyptians built the pyramids. An astounding discovery reveals they were not built by 200,000 workers or by aliens from outer space. According to archaeologists, the stones were all carved from nearby quarries, hauled on sledges, hoisted on huge ramps and set in place by armies of workers. To lift a 30-ton block off the ground would require the force of at least 1,200 men. They would have built a ramp, whether circular or straight, over 1 kilometer long that required more material than the pyramid itself. And they ended up with some sort of traffic jam until each block was placed in its position. However, recent scientific studies discovered the presence of artificial elements in pyramid stones. They found traces of a chemical reaction, more precisely, a geosynthesis, namely, the manufacture of minerals with chemistry. Thus, Egyptians built the pyramids using man-made stone, which looked exactly the same as natural rocks. Limestone blocks were cast in place. French scientist, Professor Joseph Davidovits, chemist, geopolymers and ancient cement expert, solved the enigma. He sensed the truth when he found air bubbles and fibers trapped inside Great Pyramid's limestone. He discovered fossil shells in disarray, jumbled, not in normal sedimentary horizontally layers. He confirmed the existence of the lost technology in the artisan steel, currently found in the Louvre Museum. And also with enigmatic stone vessels found in the labyrinth under the Saqqara Pyramid. The mystery was finally solved when he decoded hieroglyphs found in an ancient stele at Sehel Island, near Aswan, in the midst of the River Nile. It contains the chemical formula used by High Priest Imhotep to make the stones of the first pyramid in history, the Step Pyramid at Saqqara. Using the same formula and the same Ari-kat stone technology, Professor Davidovits replicated several artificial limestone blocks in his laboratory at Saint-Quentin, near Paris. They looked exactly the same as natural limestone. The great Imhotep, the alchemist and master architect of Pharaoh Djoser, made the stone blocks and built the first pyramid at Saqqara. He invented the Ari-kat stone technology, and here's how. Nearby the pyramids, pools were dug in the soft limestone along the Nile, forming basins for producing limestone concrete. Workers began disaggregating the crumbly rock with water coming from the River Nile. They flooded the canals to form a mud with clay. Next, sodium carbonate, called natron salt, was poured in. This salt is a very reactive substance. It is mixed with ash, rich in calcium oxide from burnt palm trees. When added to water, the resulting mixture forms caustic soda, which will trigger off a powerful chemical reaction. Then, workers added more limestone rubble and another salt, magnesium chloride, named carnallite, to lower the pH. After evaporation of water, the concrete is now ready. The limestone paste is taken in buckets, then carried to the pyramids. Archaeological digs discovered that only 2,500 people were working on site. In fact, the reagglomerated stone theory doesn't need more workforce. By means of wooden ramps and the tiers already set, men carried each bucket and poured its content into molds. Then, limestone concrete is compacted and left to harden. Wooden molds had been prepared. These molds had been smeared with oil to ease the release of the block once hardened. The mixture was rammed into the molds as in the making of the packed earth called pisé, becoming a strong and dense reagglomerated limestone. The workers stood inside the mold, pounding the wet material with a wooden pestle, packing it against a contiguous block already made, thus producing a close fit. That's how Imhotep's successors made millions of blocks for Cheops' pyramid, one of the seventh wonder of the ancient world. The Ari-kat technology uncovers a logical, simple, and proven solution to the mystery that has puzzled man for centuries, shedding light on how the pyramids were really built.